Hello. Yes, ma'am. Okay, good morning to everyone. So we announced midterm on the second hour, and then we'll discuss quiz in the third hour. So let's start with the lecture content first. Let's recap what we have learned on Wednesday. Okay, so what we learned on Wednesday was to find area. So finding here. So basically, you have a graph. X, and this graph is non-negative. And this area is bounded by x-axis with two horizontal line, x equals to a and x equals to b. And this area is exactly counted by the definite integral from a to b of x dx. Okay, and we also introduce how to find area bounded by non-positive graph here. So we wanted to find the area bounded by this non-positive graph with also the same two lines here, x equals to a and then x equals to. And to find this, so let's call this region R2 here. So the area of R2 is equals to the negative, okay, of the definite integral from a to yes. Okay. So why do we put a negative here? Because we want our area to be non-negative. Should be positive, right, area. Okay. So we put a negative here because if you consider the Riemann sum, okay, the Riemann sum, the rectangle here have negative height. Okay, so you expect that this integral term here is originally negative. So you put a negative beside a negative. So you will get a positive number. Okay, does it make sense? Okay, okay. So that's why we have a negative beside the area. So last time I promised you to show that this function x squared over 3 minus 4 is non-positive, okay, non-positive for the region -2 to 3. Okay, this is example 6.2. To solve these, you can use your quadratic method. Did you learn this quadratic method in high school? I think we repeated using this. So you have a positive quadratic, so you have a smiling face, and then you found the root. Okay, so you know where they intersect 0, and then you see which part is positive, and then which part is negative. And then it turns out that -2 and 3 lie inside the negative region. Okay. But last time I also told you that we can prove this by intermediate value theorem. So I also provide you the way to prove it using intermediate value theorem. Okay. I think you need to prepare a little bit for intermediate value theorem and mean value theorem. We will have similar question in exam like the one in lecture note. Okay, so maybe this is the other example that we want to look at. Okay, okay right. Then let's continue. Then how about we want to find a region between two curves, okay? Not just curve with x-axis, but curve with curve. Okay, bounded by curve and another. So what we do is you need to make sure that one curve always stay below the other curve. Okay, then we can compute it. It's just by the top function minus the lower function, and then you take the definite integral. So let's see if this makes sense or not. So let's say gx is this blue line here, and then fx is this purple line. Okay. So if you compute the definite integral of fx, okay, it will be everything below f and then bounded by x, correct or not? By the interpretation just now. But if you take away, okay, if you take away everything below gx, okay, is it true that you just get the I component there? If you take away, in particular, this green part here, then you are getting the area bounded by both of them. Okay, that's yeah. And it is also true that if this G here stay below x-axis. So for example, let's say if I want to find the area bounded by F and then G like that, okay, with two vertical line, Let's draw the two vertical line. Be like that. I want to find this area in between these two graphs here bounded by these two vertical. Okay. So the claim is this function, this formula also work. Why? Okay. So can you notice that actually this green region here split into two parts? Okay. One part is above the x-axis and below f, and then the other part is exactly below the uh, x-axis and above g. Okay, and then this two part is what we call the definite integral. Let's say this is a and b from a to b of f plus the negative of a to b of, let's say this is gx. Okay, does it make sense so far? Okay. Okay, no matter you are staying, the lower one is staying above or below, this formula will work. Okay, let's try this formula for an example. Find the area of the region between y equals to x squared and y equals to 2x minus x squared. Okay, so let's roughly graph it first, and then we'll try and determine what region we want to integrate. So let's try and draw this first. So y equals to x squared is very simple, just like this. But how about y equals to 2x minus x squared? Okay, how do we graph this? Okay, one way to graph this is maybe you can start by finding the roots. Maybe you could start with finding the roots. We can rearrange this graph a little bit, I mean the equation, such that we get x times 2 minus x. Okay, so these are the two roots that this quadratic have. Okay, so you are passing by 0, you are passing by 2. And this is negative, right? Negative of x squared. So it is a set phase. Okay, so we are trying to find this area bounded by. Okay, but there's some issue here, right? Do I know this point yet? The intersection point. We only know one of them is 0. About the other one, what is it? Okay, so to find it, we need to equate them first. So I want to find their intersection. So one is x squared, and then the other is 2x minus x squared. So we'll get 2x squared minus 2x equals to 0, which is 2x times x minus 1. Okay, so there are exactly two roots here. One is x equals 0, one is 1. Okay, so actually they intersect at x equals to 1. Okay. Okay, then we can use the formula just now. Okay, so from this graph here, you can see that from the graph, you can actually see that x squared is always, wait, let me see. So 2x minus x squared is greater equals to x squared when x is in between 0 and 1. Yeah. Because, so wait, let me label it first. So y was x squared, and y equals to 2x on the second. Okay, away from them, right? You can see that 2x minus x squared is actually less than or equal to x squared. But on the 0 to 1, it go above x squared. Above x squared. Okay, so then in this case, we can use our formula. Okay, a will be integrating from 0 to 1, and then take the top function minus the bottom function. Okay. And then you will get the area. And you should check that this area is positive actually. If negative, there's something wrong. Area have to be positive always. Okay. So maybe I need to make a warning here. Area has to be always positive. Okay. So actually you can show this inequality by algebra or analytically. Okay. So because we know that x is in between 0 and 1. Okay. This will implies that actually x squared is less than or equal to x. Correct or not? 0.5 squared, is it less than or equal to 0.5? Okay, so this is something that you should remember. Then we can multiply 2 on both sides. And we can rearrange to x squared less than or equals to 2x minus x squared. I move one of the x squared to the other side. Okay. Yeah, either you could use the graph or you could use this analytic way to show it. Okay, so far, any question? No. Integral is okay, right? This is just polynomial. Okay, we just skip it. Okay. In that case, how about you try one exercise? I'll let you try for 2 minutes. Discuss this. At least draw the graph, at least find the intersection. See, do we measure? Let's try and do this. Did you manage to find your intersection here? Okay, so how to graph y equal to x to 4? It's a bit like y square, right? Just a bit fatter than y square. Sorry, x square. Okay. 2x minus x squared is the same. Okay, it's the same function that we looked at just now. So it has a root at 0 and 2. Okay, it's a very similar thing actually. Okay. Yeah, so to find the intersection, so first we want to find first to find the intersection. So let x squared equals to 2x minus x squared. Then you get something like x times x cubed plus x. Okay, how to factorize this x cubed here? Cubic polynomial. Any way to factorize it? Okay, one way to factorize is you want to guess the root. And maybe you can guess, try some number. So the number to try here is should be easy number, like 0, like 1, like -1. Okay, you should try first. So for example, if you try 1, you get 1 plus 1 minus 2, so it's one of the root. Yes. Then what can you do next? You can do the long division. So you can try and use long division to calculate the other factor. So okay, so we get x squared plus x plus 2 as the another factor here. Okay, so we get x times x minus 1 times x squared plus x plus 2. Okay. Can we further factorize x squared plus x plus 2, do you think? No? Why? Yeah. If we cannot factorize, why cannot? Actually, it can, but the root is complex. So how do you say that this function doesn't has real root? How do you argue that quadratic function doesn't have real root? You need to compute your discriminant. You know what discriminant is? B squared minus 4ac. Okay, so you need to compute that b squared minus 4ac is less than 0. Okay, so there are actually only two real roots here. Okay, because x squared plus x plus 2 has no real root. Since if you compute what is b squared minus 4ac, you will get 1 squared minus 4 times 1 plus 4. Anyone know what this ABC stands for? ABC. So actually, these are referring to the coefficient of a quadratic polynomial, ax squared plus bx plus c. Right, because this thing appear at your quadratic root formula here. Okay, minus b plus minus square root of b squared minus 4ac over 2a. Because this is the thing that appears inside the square root. Okay, if your quadratic function have a polynomial, has a root, it should satisfy this formula here. Okay, but if the number inside the square root is negative, then this is not a real number. Okay, makes sense. Yeah. All right. So in this case here, then from this graph, we know that if x is in between 0 and 1, then 2x minus x squared here is still greater or equals to x to the 4. So what do you do? So to compute the area between them, you integrate from 0 to 1, take the top function minus the bottom function. Okay, that's it. and then you should compute to some positive number. Okay. Yeah. So if you want to show using analytic way, how do you show this? Okay, for 0, x in between 0 and 1, actually x to the 4 is less than or equals to x squared, even smaller. Okay, so we just now already showed that x squared is less than or equals to 2x minus x squared. So you will get this inequality as well. Okay, so far. Any question? Okay. Would you ask a question that why not our graph look like this? Or maybe we shouldn't look like this, right? We shouldn't look like this, non-intersecting, because both of them gonna intersect at 0. Okay, and then your y equals to 2x minus x squared intersect at 2. So definitely have to go out a little bit and come down. Okay, so there will be a region that are bounded by these two graphs here. Idea. Okay, this one not working. Okay, I'll just open. Okay, thank you. Okay, thank you. Yes. Yes. Okay, thank you. Okay, good. All right, so just now we have been integrating this area first, but actually, did you notice that these calculations are based on the Riemann sum? Okay, the Riemann sum that we put is like this. Okay, vertical. Okay, these are the vertical rectangle that we refer to. But actually, we can compute horizontally as well. Okay, actually, we can compute this area horizontally. So how do we do that? So let's say our graph. So you can turn your head, rotate your head 90 degrees. Okay. So let's say instead of we have y equals to some function in x, we have x in terms of y here. Then we also can compute the area that bounded by these two curves here. Okay, so maybe you can turn this diagram a bit. If you like, I can turn it for you. Right, so I can turn it. G is at the bottom. Okay. Right. Okay, so if you turn it sideways, then this is what we have discussed before. Okay, so actually it's a similar thingy. So what we should have here is we want the right hand side. Right hand side is larger x, right? Let me label it. So for example, G is around maybe 5, and then F is around maybe 10 like that. Okay. So we want to say that the right function is greater or equal to the left function here. And then to compute this, we also take their difference. Okay, take their difference and then integrate along the y. So integrate along the height. Okay. Instead of integrate along x, we integrate along y. And because if we turn the side line, you can see that this y is like acting like x. So far, make sense? This one. Picture or question about the picture? No? Okay. In that case, let's try some examples here. Okay, so let's see when should we apply this kind of integral. So let's look at this question here. Find the area of the region bounded by the two parabola y squared is to 4x and the line 4x minus 3y equals to 4. Okay, perhaps the line is easier to draw. So to draw this line, right, should we first find the y-intercept here? So what's the y-intercept for 4x minus 3y equals 4? Y-intercept means what? X have to be 0. So if x equals 0, y is, what's y? I will say, if x equals 0, what's y for the line? Huh? 0? You put x equals 0, you get y equals 0. Then you get 4 equals 0. This is a contradiction. What should you get for your y? 4 over 3? Minus, good. So minus 4 over 3. Okay, so you intercept at minus 4 over 3. And then what's your x-intercept? When y equals 0. So if you put y equals 0, okay, let me. So for x minus 3y equals 4. If x equals 0, y equals to minus 4 over 3. So if y equals 0, you get x equals to 1. Okay, so this is your line. Okay, how about this parabola? Xy squared equals to 4x. So there are 4 directions you can pick, right? This one, x squared, or minus x squared, or some other 2 parabola. Okay. Obviously, we need to throw the x squared away because this is y squared. Okay, so then you need to pick the other 2 directions. So which one do you pick? You pick the right direction because y squared is always positive. So 4x equal to something always positive is x will be always positive. Okay, so actually your parabola face to the right. And then the question asks you to find the area bounded by these 2 curve here. So did you see an area here? The region. Okay, so you want to find this. Well, to find this, you can use the method we learned before, right? Take the top function minus the bottom function, okay? But if you notice that the bottom function here changing, is changing. Okay, so for example, if you want to use the previous method, you can see that from 1 onwards up to this, I'm not sure what is this. Later we'll find it out what this point is. Up to this point here, A, let's call it A first. Maybe let's call it B. Okay, so 1 to B, the top function is y squared equals to 4x. And then the other one is 4x minus 3y equals to 4. Okay. But then you need a function in y, right? Okay. So this part here, how do you describe this part here in y? With y in terms of x. Yeah. This part here. Can you write this part as y equal to something? You need to be able to express this as y equals to some function in x. You need to express your y in terms of function in x. Huh? Is it possible? So what I meant is you need to be able to find what is fx, but you know that fx square is 4x. You find what is fx. You know fx square is 4x. How do you get from square to non-square? Square root, right? Okay, but there are two choices, right? Either positive or negative. So you will get like square root 4x and y equal to negative 4x. Do you still remember the circle thingy? The circle. So your circle equation is y square plus x square equals to some radius square. And then there's a upper circle and lower circle. So the top circle is y equals to square root a square minus x square. And then the bottom one is a equal to square root negative square root x square minus x square. Okay, so this is exactly what happens here. Okay, so you split the parabola into two parts. Okay, the positive part and the negative. Does it make sense? Okay, so from 1 to b, square root 4x is the top function, and then bottom is 4x. Should I write it down? So let's write down a equals to integral from 1 to b of square root 4x minus, what's this? Y equals to 4 minus 4x over minus 3 like dx. Okay, so this is the first part. But the second part, okay, what about the second part? So second part here, you see, the top function is again the square root 4x, but here got two types of bottom function here. So there are two types. Okay, so you need to split it again. Okay, you need to split it again. So you need to split it to this intersection. Let's call it C. Okay, so 0 to C and C to 1 is bounded below by different function. Okay, so if you want to use the method we had just now, you should compute what is function from 0 to C, which is square root 4x minus square root 4x dx. And then the other one is integrate from C to 1 of square root 4x minus 4 minus 4x over minus 3 dx. Okay, seems like 1 to b, c to 1 is the same integrand. So actually we can combine them here because actually the top and bottom is the same function. Okay, so maybe you can compute this. Okay, but we're going to use horizontal slicing to compute. So meaning we're going to see it in the horizontal way. Okay, we're going to see this area in the horizontal way. This will make this integral easier. Okay, maybe you can try compute this and let me know. Okay, you can send your solution to me later on. But instead of doing this, we'll use the horizontal one. Okay, but to use the horizontal one, instead of finding what is y, okay, we want to find x. Okay, can we express this function in terms of x or not? I mean in terms of y, x in terms of y. Okay, so for this parabola, right, we can easily arrange it to x equals to y squared over 4. Okay, similarly for that line, we can arrange it to x equals to 4 plus 3y over 4 like that. So you can notice that for the region of y, where is the y we want to find here? So there are two horizontal lines we need to determine here. So one of them is the top one, and the other one is the bottom one. Okay, within this region here, right? This linear line here is far right than the parabola. And so you can take the far right one minus the left one. Okay, then we need to find what is what is this horizontal domain? Okay, the domain that we want to integrate over. So meaning we want to find their intersection. Okay, let's find their intersection. So let's find the intersection point. Can you calculate it? Okay, instead of doing that, instead we use horizontal slicing. Okay, let's find their intersection. Okay, so how do we intersect them? Well, first, we find their intersection point. For x minus 3y equals 4. Let's get what is x first. And then we will put it back to our parabola. So y squared will be equal to 4x, which is equal to 4 times 1 plus 3 over 4y, which is 4 plus 3y. And then you rearrange a bit, you get y squared minus 3y minus 4 equal to 0, which we get y minus 4 times y minus 1 to be 0. Okay, so 1 over y is negative 1, 1 over y is 4. Okay, so you can see that I purposely find x first, such that in the end I just find what is y. If you do it in the other way around, you let y equal to something and then start it back, then you will find something in x, and then you need to find y again. Okay, so we make our life easier. Compute x first, and then we find y. Because what we really need is just y, it's not the x. You need x if you do the vertical slicing like we did just now, the b and c here. Otherwise, to find d and e, we can do this. So 1 is negative 1, 1 is 4. Carry off this circle. Okay, 1 is 4. Okay, so by this theorem here, to find the area, we just integrate from negative 1 to 4 and then take the far right function. So far right function is 4 plus 3y over 4, and then the left one is square root 4x. Is it? Wait, wrong. So not square root 4x, what is it? Y square over. Okay, so everything is in y. So you need to check whether this integration limit, where do you take it, and then the function, and then the variable, are they consistent or not? Okay, like what I said yesterday. Okay, you have to be consistent. Okay, you cannot integrate along x and then your function is along y. Okay, any questions so far? Any question? Integrating this one is okay, right? This is just polynomial. Okay, so I urge you to try and compute it. Try to check it. Okay, so if you can compute this two-way, you can check whether do they get the same answer or not. Okay, so to convince yourself that these two compute the same thing, and then to make sure that you know every method to compute your area. Okay, any questions so far? So far, any question? No? Question? No? Okay. So how about try the last one and then before we take a break here, try this. Yeah, see if you want to use the horizontal one or you want to use the vertical one. Sometimes you can do both. Then you can see whether you know all the method. Yeah. After you look at this, maybe uh, let's try. Yeah, let's try. So do you know how to find this pi over 4 intersection here? You know how to find it? So basically you just set cos x equals to sin x, but this is not quite polynomial, right? So you can't really like take sine inverse, cos inverse. That I think that be making life even harder. So how do we really find this then? Well, I think one thing you need to remind yourself is this function is periodic. It's periodic. So there's a way to get from sine to cos and then cos to sine. So to get from sine to cos is you just move your x by pi over 2. Okay, so I mean, how do you remember this? Well, you should remember the basic graph first. Okay, so there's a pi, there's a 2 pi, and then pi over 2, and then pi, 2 pi over 2. And then how about sine x here? So sine x is, okay, so this is pi, 2 pi, and 0. Okay, this is the three places where sine get to 0. And then all the peaks at pi over 2, and then the bottom at 3 pi over 2. Okay, so if you move your cos, okay, maybe let me draw a little bit more because this is periodic, right? So if you move your cos to the right, yeah, maybe I draw one more bit here. Okay, if you move this sine graph here to the right, okay, let me draw them in one. Okay, let me erase them. Okay, so maybe let's start with here, like that. Okay, too far away. Wait, this go up, go down, further down, and then yeah, a bit further away. Go up, go down, further down, up, like that. Okay, so if you move this cos graph here 90 degree to the right, then you exactly get a sine. Okay, make sense? Okay, all right. So in this case here, I think this is easier, right? Cos x equals to x plus pi over 2. Okay, so you need to ask yourself when cos x have the same value plus pi over 2. Okay, so if you look at the cos graph here, right, it is kind of a symmetric across pi. Okay, it's kind of symmetric across pi. Okay, so do you get what I meant here? So if you draw a vertical line along pi here, right? Okay, it's actually symmetric. So you want an x, you want the cos x that's equal to x plus pi over 2. So you want to get same value on this constant. And so meaning you can split the pi over 2 across this pi here. So how to evenly split it? Pi over 2 divided by. Okay, so you want pi over 4 before pi or after pi. Okay. Uh, I think the claim is pi over 4. So this happens at x equals to pi over 4. Or you can do a sanity check here. So you can try and press your calculator. Is it true that cos pi over 4 equals to cos pi over 4 plus pi over 2 is what? 3 pi over 4. Okay. Okay, so we really only care about one of the x's, which is in between 0 and power 2, which is power 4. So this is the part that we care about. Okay, so for these two parts here, how do we integrate? Maybe we just discuss orally which one is the top function, which one is the bottom function. Depends on the interval you integrate. Okay, so from 0 to power 4, the top one is cosine x, and then you need to take away the bottom one minus sine x. But if you try to integrate from power 4 to power 2, the top one is sine x, and then bottom one is cosine x. Yeah, then you just do that calculation. Yes?
Is it same value? So we can just integrate one side and just multiply by each other.
Oh, you mean is this symmetric?
Yeah, yeah. Symmetric by P over 4.
How do you show that?
Because
Let me think.
it's just
Uh,
I look at and say
let me think. Let me think. So yeah, well, I mean, okay. So if you really want to do that, wait, is it true or not? I think based on calculation is not true also. Seems like not true. Okay, I mean, because this is the calculation I made. So let's maybe that picture is a little bit misleading. So this is the calculation I did. So I split into two parts, and then put water function different for the two parts. And then if you can notice that for the first calculation, right, I start from sine power 4 up to -1. Then the other one is the rest. So I think this two number is a bit far different.
the same.
The same?
Yeah,
Okay.
it's the same.
Where? Where is the same?
Based on the calculation, it's the same.
Uh-huh. This one? This one? Yeah. Square root. So this what's the sine power 4 here? Sine power 4. Square root over 2. So this 2 square root over 2 is coming from here, right? Both of them is the same because we just now proved that x2 is the same number. And then what happened to here? Oh, I straight away add them together. Let me check. So yeah. So you mean both of these are just square root of minus square root 2 minus 1, both of them. Is that right? Okay, then it's a very high chance that they are symmetric. So how do you show it? It is symmetric if you want to do it. Let me think.
Like
Ah,
symmetric divided like P over 4.
Mm.
Like this side and this side.
yeah, definitely.
And then, like also same.
I also say.
So
Yeah, so how do we like explain the height also same? This is the point. Let me think about it. So how do you write this properly if you want to show symmetry? Because previously, right, when we say symmetry, we are symmetric across 0. So there's no shifting you need to do. But here, seems like you need to do some shifting. You understand what I said? You need to treat your pi over 4 like a 0. So you have to do some shifting. Huh? Yeah. Right. So how should we do this? Let me think. So instead of discuss about cos x, right? Maybe you can discuss about cos x. If we want to move to the right, left, left or right, left. So I think we need to consider this. This. So the claim is this two function is symmetric. Oh, uh, yeah, wait, So, yeah. So like what we did last time, right? We want to make sure our function is even, right? So how do you check even? Okay, so this is something extra. This is something extra. We try to figure out what is symmetry. Just now the question we already solved, right? We already know how to find the area. So now we're trying to show that it is even. Okay, along the pi over 4 here. So what you do, I think you should compute cos of minus x plus pi over 4 like that. Obviously, we don't want to express it as a cos again. So is it possible to relate to sine here? So just now we have an identity of we have this identity, right? Sine x equals to cos x plus pi over 2 here. Can we go backward? So meaning this is equals to cos of negative x negative plus power 4 minus power 2. Do that. Do that. Is it true or not? Such that we get sine of negative x minus power 4. And not close to what we want, right? Oh, I think I'm wrong. I'm wrong. I'm wrong. We shouldn't. So let's break here. Let me try it. So let's break until 10:09. Okay. For those who want to listen how to figure out this, you can try. If not, you can take a break. Yeah. Yes. Yeah. Yeah. Yeah.
With
Also,
like-
later we'll discuss.
X, then I should find the Y, so it's extremely.
Okay, later I will discuss.
Okay.
And then you'll see. Okay, so how do we figure out this? Okay, let me think. I think we shouldn't do this cosine thing. I think I have to do this. Maybe write down what we want to show first. Yes. Where? This one? This one? I mean this will help us to find x equals to power 4. Because if you just cos power 4, sine power 4, then how do you test until power 4? It's a random test. But if you know that cos x equals to cos x plus power 4, you can reduce the number further. Because you should know that there are two degrees that give you the same cos. And then you try from these now. Otherwise, cos x equals sin x is like a lot of number to try. Yeah, I think, Madia, you need to take negative x to do this because x is going this way, right? And then you want to show that sine x is equal to cos x going the other way. So I think you need some negative x to come in.
Like we should
Like for example, right? For example, this you want cos 0 to be equals to sine power 2. And then you want cos of power 4 equals to sine power 4. Yeah, I mean, let me try and write down the full argument for this. Yes.
Yeah, it's not the triangle because sometimes it can be like
You mean this triangle here? So you need to read the question, right? This is the area of a region bounded by two curves with x equals 0 and then pi over 2. So you have two curves, you have these three. It's they didn't say x axis. If they say this two line and then with x axis, then this is the triangle. So you need to read the question. What are the line involved here? So it's very clear that this is the region that bounded around the sphere. Okay, for this symmetry one, let me try and sit down properly and then I'll try and write it out in full. If you figure out, you can send me also. Right, let's take and then 西和 here, okay. 乐天 乐天 here. 瑞阳若实诗曼益南玉涛 is 玉涛 OK 一则对啊一则个译文个瑞言泽汉加来嘉义齐军军嘉义疫情俊逸相思义林冰珍嘉滩奥云文琪汉祥 俊杰，新阳，新阳 K，万达，新月，玉恒，一田，冰城，苗冰城，傲然Desmond，Tommy，琼一，Missing，林杰，Pagani，Arthur， Jose got Hisham, front, Daniel, down here, okay. Hashim, Hashim here, no? Hashim, not here. Madia, got Brandon has got Brandon, okay. Alicia, got Gunakanti here, no? Gunakanti. Margaret got Javed here, Javed not here. Gabriel here, not here. Jeffrey, the back. Purity got, yeah. Tân Phan, Gia Thiến got. Yeah, got Hồng Liang. Okay, good. 对，没有错。
这个不是，这种不能，不是跟图像一样，这样写。对，应该是这样。
哦，我有说这两个才能当这个东西发生的时候
就是这个
啊，就是
这个点
啊，
他刚刚是想证明，就是
他要证明什么呢？他要证明的是这两个是相同的，这两个的 area 是一样的，所以我算一半就好。还是
不知道怎么证明一样的，
怎么证明一样哈？
对称
怎么证明对称没有错，证明对称，
太
要证明对称。
证明这两个是一样的。
对，因为现在不能够直接说它是 even 嘛，因为一个是 cos 一个是 sin 嘛，那我们应该要透过 sin 跟 cos 的一些关系来看它是对称，就是
就是说这两个命是相等，
对，然后它算一半，
那成功的证明
还没，我来讲一下要怎么具体写，
斜率吗？
不用，应该只要用这 cos 的东西就好，应该要呀，只要我觉得我们只要证明到。我们只要证明到这里的高度跟这里的高度是
Maybe
Yeah.
we can prove like
Yeah.
cosinus p over 2 minus x equal to sinus 6
cosine
cosine
yeah
and
over 2 maybe sine
cosine
2
minus 6
minus x
equal to sinus 6
yeah something like that yeah
and sinus p over 2 minus x is equal to cosinus 6.
so
And-
wait so from here then
Like in and the otherwise like sinus p over 2 minus 6 equal to cosinus 6.
and then
We
Equate
prove
into-
like it's like same in that cases.
same in this region here
Yeah.
then this region here
Yes. And
Yes.
so also we know that if you put the number 0 it equal to 1 and put the number p over 2 is equal to 1. So this two values is equal and they bound like they intersect with each other in a halfway. So because of it it's like symmetric. I don't know.
Yeah you want to try and write it out
Yeah.
you try and write it out then send me
No,
you write it out and then send me yeah
这样子，我自己找到
OK 啊，I think 一样嘛，不是
这样
？Yeah, I guess so. Let me check 啊，一样的，一样，一样。对，他要用 symmetry，所以我们 try 看能不能用 symmetry。
是不是？
OK，good， yeah，什么？哦，你可以拍照发给我吗？直接送给我。对，好，谢谢。OK，right. Okay, so announcement for your midterm. So if you look at your Moodle announcement, you check your Moodle announcement. So when is it? You want to tell me the time, the date? So the day is Friday, right? Okay, what's the date? 28. So it's 7 days from today, yeah? What time? 7 p.m. to 9 p.m. It's quite late because some of the class end late. So what's the venue? A4 111 111. Okay, so first floor. Okay, so please come earlier to prepare. We won't wait for you. Then what else? So this test is until derivative. So week 1 up to differentiation. Okay, everything before integration. Yes. Okay, so no integration. How much question? Does it really important? Why?
How much?
Okay, so for the question numbers, right? Obviously, we will set it such that you can finish in 2 hours. Yeah. 有回答就没有回答这样。So obviously we will like take into account that you can finish in 2 hours. Yeah. So even if I put one question, maybe that question is super long, right? So obviously we will make sure that it's 2 hours. Yeah. Okay, if you're really curious, I think it's about 5 to 6. Yes. Yeah. Okay. So this is the problem, right? If I say 10 questions, what if the 10 question is very small? So this is like cannot comparable. So the point here is it is a 2-hour exam. Yeah. So you cannot use number of question as a unit. It's not accurate. What if the question got ABC? So how do you measure? So it's not accurate. So what's accurate is we have to be accurate. The lecturer has to be accurate. Okay, we should give not too long exam. So we try to set our exam such that it can finish within 2 hours. That's it. Okay. Yeah. Other question, for example. Oh yeah. Another thing is this day the lecture, right, shortened to 1 hour because we take 2 hours for exam. So lecture on the day. So let me put here. So this day we got lecture, right? Like this morning here. Lecture on the day change to 10 p.m. to 10 a.m. to 11 a.m. Okay. So we don't try to start at 9 a.m. So we just do 10 to 11. Okay, so for this, what's the content here? You want to design the content here. Maybe you can bring your question here, revision. Bring your textbook problem or what. Okay, so let's discuss here. Okay, so try and do some exercises. Not sure, then come here and ask. Or concept not sure, you can come here and ask. Bring your question. Okay, bring your question. Okay.
Will be paper based.
Paper based, yes. Yes. Bring what? No need, we will provide in the exam paper. Yeah, what's wrong? What's wrong? What's wrong? Oh, is it? Yeah, okay. So it's different here. So no cheat sheet. Yeah. So no cheat sheet here. Okay, we provide enough formula. Yeah, so make sure you are familiar with using them. Okay, familiar with using them. Yeah. I think for like sine square plus cos square equals to 1, we don't need to provide, right? You should know very well, right? Like for example, let's say got what thing. So let me give you some examples. So for this kind of identity, you should be very well familiar, right? Okay, maybe the sine 2x1 you're not familiar. This kind of thing we will give you. Right, this thing. If you can remember, you are brilliant. But if not, I can give you this one. Okay. But 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 sine square x plus cos square x equal to 1, you should like know very well. Otherwise, you are not a mathematics student. Sine 2x maybe is a bit hard to divide with you. Anything that can be derived from sine square x plus cos square x, you should be familiar. You can divide everything by cos square or divide everything by sine square, such that like you get tangent square x plus 1 equals to secant square. Huh? Yeah. What is what? Huh? What is what? Or if you are really desperate on the exam day, maybe you can try and ask us, see if we can give or not. If you are really desperate. Maybe there's something that we miss out, who knows? But we try to give. Okay, when we design the exam, we try to give enough material to you such that you can use them to calculate. Not asking you to recall things. Okay, we just want you to see whether you can do chain rule or not, product rule or not. Those formula we won't give you lah. We won't give you product rules formula. Those things you need to be very familiar. In particular, the position and U and V. Please don't confuse. The position very important. Which one you take derivative first, which one you take derivative next. Okay, those formula we won't give. Chain rule, product rule, some those rule, yeah. Okay, but this kind of identity we will give you. Like squeeze theorem, we probably won't give you, but intermediate value theorem, big value theorem, we will give you. Squeeze theorem, you should remember. So, we just cite inside the question that need to be used. We already provide you, or you have to use this or you know what to use. Okay, yeah. But like squeeze theorem, we won't provide. Squeeze theorem is very straightforward, right? You squeeze by two functions and then you find the limit for the both bound and then yeah, squeeze theorem. Do you still remember? Yeah, you should do some revision. Okay, any other question for exam? Okay, so next week Friday only got 1 hour's lecture. So please bring as many questions as you can. Okay. Okay, so next hour we're gonna discuss quiz 2, okay? Last 20 minutes. So right, so let's continue. So next, after finding area, we are trying to find volumes. Okay, so the volumes idea is very simple. It's area of the base times height. Again, like the rectangle. Rectangle is what? Length times width times height. But length times width is the area. Okay, so basic idea is area times height. Okay, for any prism here. Don't care what's the shape of this base. If the base is rectangle, then this V is a rectangular shape. And what's the solid of rectangle? Rectangular box. What's the solid for rectangle? What do you call that? Rectangular. So rectangle is 2D, right? So what's the 3D? Cube. Cube is square.
Parallelepiped.
Parallelopiped.
Yeah, like that.
Parallelopiped. Parallelopiped.
Yeah.
Parallelopiped. Like this.
No pipe. Pipe. See.
Let me see. Like that. Parallelopiped. So if you are a square base, you will get a cube. Okay, so in general, it's a prism here. So, and then how about for general solid? So for general solid, what we can do is we can put it in the XY plane. Okay. Actually, XYZ, XYZ plane here. And then you cross out a cross section here. And then you add up all these cross sections together. Okay, so you add up all of them. And so you know one piece, and then you take the multiple of this piece. So to do this, this is what we call the integral of AX. Okay, instead of just some number height here, okay, this AX here depends on height. So area of the cross section depend on height or X. Okay, because at every X, this cross section could change. So previously, the cross section remain constant in the same shape. Okay, but we can do it for a different shape. This is integral. So this is the picture here. Okay, so the Riemann sum here. So there's a Riemann sum here. So this Riemann sum here is like it, not like rectangle. It's just some sectional with a thickness here. Okay, does it make sense? Can you relate back to your Riemann sum? Instead of the rectangle below the graph, it becomes some cross-sectional shape. And then you imagine that when this cross-section with thickness here getting smaller and smaller, it really assembles the volume here. That makes sense? Does it make sense? So you can think of a Riemann sum like a low resolution. You know what's low resolution? You watch YouTube. You watch TikTok. You know low resolution, 360p versus 1080p. Okay, so this is like a 360p. This is like 100,080p. Okay, you can see the real solid. But this one is got something not clear here. Understand? Okay, I think you are a computer science student, right? You should be able to appreciate this. Okay, so this is a 360p, so 100. Okay, makes sense, huh? So when your limit tend to infinity, your solid get very thin. Okay, this is the real solid you get. Okay, so let's see how do we apply this to calculate. So if you're at a plane region here lying entirely on one side of fixed line on X plane, so this case here, there's a plane region that lying entirely on one side of a fixed line in X plane, so fixed line here is y equals 0, and revolve about that line. So revolve is like you rotate, and you rotate this plane here. And then you will generate a solid of resolution. So you generate this kind of like a speaker here. So you can see that there's like a circle coming in here. The circle, right, because you rotate. So there's a circle here. So now you want to find the volume of this solid revolution, okay, obtained by revolving the plane R bounded by this y equals square root x. And as x-axis, so there are three lines here. So just now Felicia asked well, how to find the plane region. So first you got y equals to square root x. Second, you got x-axis. And then third, you got x equals to 1. So it's clear that this is the region you want to look at. Okay. So there's a circle here. Okay, so there's a circle here. And then there's a lot of circle here actually. Okay, a lot of circle here. So at the low resolution, right, 360p, for example, you actually can see a what's this? How do you call this? A pie. Not cylinder. What do you call it? A disc. Okay, a disc with some thickness here. Okay, a disc with some thickness here. But you want the thickness to get to 0. So this delta x here, you want it to get to 0. Okay. So what we're going to do here is this v here is just integrating from 0 to 1, okay, of pi of the radius square. Okay, so radius here is y square dx here, okay, which is pi of square root x square dx. Okay. Because dx here actually represent the thickness. Okay, represent the thickness here. Actually, this delta x here is this dx here. Okay, but if you still remember in our Riemann sum idea, right? The height is the thickness there. The height. Oh no, sorry. The width is the thickness there. But the Riemann sum is the width getting to 0. This is the same here. So you have a lot of this here. So you have a lot of like 360p stuff here. But this doesn't quite look like our solid yet. So we need to take a lot of this with the width thickness getting to 0, such that it becomes a circle or a disc without distance inside here. Okay, does that make sense? Okay, so this is the relation between Riemann sum and this volume here. Okay, so to compute this, I think it's easy, right? Just pi x square over 2 from 0 to 1. Okay. But everyone can think about this question using Riemann sum. Or question? Any question? Question or question? Okay. So do you know why we use pi r square here? Because this is the area of a circle. Okay. So you got the area of a circle here times with the thickness here. Okay, so here's pi r square. But your r is controlled by your y. Okay. And then you take integration. It's like you do in Riemann sum, the rectangle becomes small rectangle. So this here, the thickness of the disc also become 0. Okay, so it become a bunch of disc without thickness here. Okay, make sense? Question? Okay, if no question, should we try another one? Okay, let's try the other one. We can turn this around like how we turn our area just now before. Instead of revolve around x-axis, we also can revolve around y-axis here. Okay. So let's look at this region here. We want to revolve around y-axis. Okay, do you want to try? What's the integral you want to set up here? Where do you and until? Okay, you read the question and then you tell me what's the integration domain. Okay, read the question properly. So what's the region that get bound? So what's your integration domain here? Yeah. Okay. Along y.
Y.
Along y. Yeah.
Like x equal to
Yeah.
root square y.
Sure. Okay, so this is the function we look at. So what's your integration domain? Limit
0 to 8.
from 0 to 8, y? No? True, right? Because what's the curve that bounded this region here? There are three things, right? One is y equals to x squared, x cubed, sorry. The other one is y-axis, and then y equals to 8. Okay, so you need to check that this intersection of x cubed with y-axis actually is the origin. Okay, and then the other limit is y equals to 8. So why we integrate along dy here? Because we realize this in the y direction instead of x direction here. Okay? And then our thickness happen at y direction. And then how about our radius? What's our radius here? So our radius here exactly controlled by the y equals to x cubed curve here. Okay, y cubed curve here. So you need to put the x squared here. But what is x here? So you need to solve it by x of cube root y, x squared. Yeah. Okay. So you can notice that actually this is quite symmetry, right? Where I also can ask a question that you can also take this side here, right? Where x equals to minus cube root y. I also can do this. I can use this radius here. It's the same. If I use the other curve to evolve. Okay. Yeah. So far, any question or not? So you to appreciate this formula here, you need to understand where you get your this from. Okay, you need to understand where do you get your this from here. So this is your radius, and then this is your dy. Okay, your thickness happen in y direction. But once you take this integration sign here, so this integration sign, well, send dy to 0. Okay, like the case of Riemann some rectangle. Okay, the rectangle. So instead of using the rectangle to measure the area, you will use this disk with thickness to measure the volume. Okay. Any question? Area. The base area, right? Base area. Okay. So instead of using rectangle, we use this with thickness. Okay. So next, sometimes so you can see that if we have two curve like that, and then we want to evolve this two curve here around x-axis, for example, then this will form something called a washer. Do you know what's washer here? Washing machine. Okay, it's like a washing machine. Yeah. So there's a hole inside here. Okay, so there's a hole inside here where you can put your shirt. Right. Okay, so this is the washer. They call it a washer. So in this case here, there's two radius you need to look at. So there are two radius you want to look at. So maybe radius in controlled by one function, and then radius out controlled by the other function. So what's the next thing we want to do? Obviously, we want to find the volume. So how on earth we're gonna do this? Okay, well, I guess the area, you should know what happens, right? How do we compute the area that can give by this region here? Okay, so the area here, if you look at the revolution of this area, right, should be pi of r out square minus pi of r in square. Okay? And then you back into the integration sign later. Okay, everyone happy with this? The area is the difference between these two areas here. Correct or not? Correct. Because this hole here actually is the area given by pi r in square. Okay, makes sense? The outer one definitely include the area inside. And so if we want to remove the solid that's revoluted by this radius inside, then we need to take it away. Okay. Okay, let's try this. Any questions so far? Question? No? Okay, let's try this. So let's find the volume of solid generated by revolving the region bounded by parabola y equals to x squared. So let's draw it. And y squared equals to 8x. Okay, so just now we decided y squared equals to 8x is the parabola facing to the right. Okay, so the A region bounded by them is this I like region here. So you're gonna evolve this. Okay, it's like a leaf. So there's a leaf and then you evolve it. Okay, imagine the leaf here. Okay. Right. So how do we do this? So first of all, definitely we need to find what is the intersection point. So one of them is 0, very obvious. But the other one, how to find it? So again, we want to find the intersection point. Okay, so intersection point is x square, which is x. Okay, so I sub y equals to x squared into y squared equal to 8x. And then we can get x to 4 minus 8x equals 0. And then we factorize it. And then you further factorize. And then you found out that one of the part has no real root. You can solve it in complex, but not real. So there's only 2 real root, which is x equals 0 and 2. So in the case, this blue line here is x equals 2. Okay, so you need to argue that x squared plus 2x plus 4 has no real root. Use the discriminant. All right, so we want to compute this washer. Okay, so we just take what is R in and R out here. So what is R in? R in controlled by which function? R in. Y equals to x squared. Good. So you can put here, this is a washer. This is a washer with R in controlled by, so radius is in the y direction. So R in is controlled by x squared, controlled by y equals to x squared. And then R out is controlled by, R out is a bit trickier. R out is controlled by what? Can you express it as y equals to something? So this outside here is actually y squared equals to 8x. So just now we split the parabola into 2 parts, right? because this is not a function if you consider the vertical line test. So you need to write it as y equals to square root 8x. So the top part here is y equals to square root 8x. And then the bottom part here is y equals to minus square root 8x. So one example you need to keep in your mind is like a semicircle, right? Above is positive, below is negative. Okay, so then the calculation will become, so the volume is become integrating from 0 to 2 in the x direction, pi of r out square minus the r in minus square. Okay, so one way to think about this is, let me remove the picture here first. So one way to think about it is you take the radius outside, you form your disk with thickness, and then you take away the smaller disk. Then this is the washer. Okay, can see or not? So you take the larger disk. Okay, you take the larger disk outside. Okay, and then you remove the smaller disk inside, and then you get a washer. Like drilling, 打洞 drilling. Okay. Right? Okay. So you are drilling in the R inside. And you remove the radius inside. Okay. Question? Any question? So far okay. All right. Any other question to try? Yeah, we should try one more. I let you try this one. Okay, you try this. Try and set it up. No need to compare everything. Try and set it up first, and let's check whether what you said is correct. I give you about 2 minutes. Try and set this up. See what is R in and R out. Okay, so let's see our shape correct or not. So it is a semicircular region divided by a curve of x equals to square root 4 minus y squared. Okay, so where is this semicircle? First quadrant and the fourth quadrant here. Okay. So because x is equal to square root of something, so must be positive. So it's everything on the positive side of the axis. And then this is something that satisfies x squared plus y squared equals to 4. Right? So this radius here is actually 2. Okay, so we can have a -2 and 2 and bottom like that. And then this point is also 2. Bounded by this region and y-axis. Okay, so actually it's this part here. But revolve at the line of y equals to -1. So let's draw this line. Okay, okay, so it rotate something like this. Perhaps I can draw this out like that. Okay, so this is a washer. Okay, this is a washer here. So beautiful. And so this is the washer. So where is the R in and R out? Okay, so the outer one is R in. Maybe I use the sorry, this is R out, outside, right? And then you drill the hole inside here. So maybe I use another color, but I labeled it using. Oh, maybe this is a bit confusing. Okay, how about I use this with different color? That's okay. And then green one is R out, and then purple one is R in. Make sense? So far, question? Go question. Okay, so then we will say that this is a washer with R out. So what is R out here? Is it just so where's the radius? How do you measure from x equals to -1 all the way up to this boundary of your circle? Okay, so we know that this circle is controlled by square root 4 minus x squared. Okay, so is it enough that I put square root 4 minus y squared here for your R out? Is it enough? Where do you measure your radius from? You have to measure from your axis. Okay, but did you notice that your circle only measure from x equals to 0? Okay, so you need to add the extra one here. Okay, you need to add all the way from your evolving axis here. Okay, so actually your R out is 1 plus the semicircle. Okay, and what is R in here? What's your R in? R in is just radius 1. Okay, it's like you're taking away a cylinder. Okay, you're taking away a cylinder from this circle revolving. Okay, you take away a cylinder. Okay, can you imagine or not the cylinder here? This is a cylinder.
How is equal to 3 or not?
R is equal to 3. What do you mean?
Like
Hmm.
from 0 to 2 and from -1 to 0, it's like overall is 3 on.
Oh yeah, sure. So yeah, sure, definitely. You see this 0 to -1 to 2 here is 3, right? So how do you see 3 here? 3 is exactly at the slice of y equals to 0. Is it true? 1 plus 2 is 3. Yes. Yeah, so this is just one slice. But that is why the power of this integration is I add different slices. You see? Did you see the slice here? Did you see the slice? So there's a lot of slice here, right? There's a lot of radius here. But the power of integration is here is you can do all the slices together. You integrate all of them together. Okay, so the zero, so like what Madia asked just now, when you look for this when you look for this radius of 2 minus -1, right, which is this line here, this black line here. Okay, this radius here is 3. So where is this 3 come from? This is the R out at y equals to 0, which is 1 plus square root 4, which is 3. Okay, no. So the point here of this R out is like I look at all the R out together. Okay, at once. Make sense? Okay. Yeah. Then this has the cross-sectional area as AY to be pi of R out square minus R in square. Okay, which is pi of 1 plus square root 4y square minus 1 square. Okay, which is pi times 4 plus 2 square 4 minus y square minus y square. Okay, then what do? So the volume is you integrating from -2 to 2 of this AY. Okay, so pi of 4 plus 2 square. You need to integrate this. Okay, so there's a very tricky part to integrate. And we haven't learned any technique to integrate this guy yet. But did you realize that this is a semicircle? So you should use the geometric method to calculate this. Okay, so this is the area of geometric, so area of a semicircle. Okay, later on we will learn integration by part R or trigo integration such that we can compute this guy here. Okay, otherwise now you just use area of a semicircle to compute it. What is this? This is a semicircle. This is this semicircle, right? This one. So what's the integration from -2 to 2? So this is the area of the circle divided by half. Okay, so this is the definite integral of the square root. Okay, any question? So far, questions? Okay, I think integral is standard, but any question of reading this washer here, getting the R in, R out? So the technique you need to learn here is get the picture right, and then decide what is R in, what is R out. And then you just use the washer formula here. Okay, any question on getting this R in, R out? Radius inside, radius outside. Okay, I think very important is you get the first picture right. If your first picture is wrong, then your R in, R out will change already. Yeah, so make sure you get the picture right, and then get the evolution right. Okay, so far so good. Okay, how about let's do one or two more before we take a break. All right, so 6.11. Let the base of a solid be the first quadrant plane region bound by this y equals to 1 minus x squared over 4. The x-axis and the y-axis. Suppose that the cross-section perpendicular to the x-axis are square, find the volume of the solid. So this is a bit different from what we had just now. So this a bit change a bit of tempo, change gear a bit. Okay, so this is not really a washer thingy, but I'm not sure why it appears here. So let's get the picture right first. Picture looks like this. So let's draw 1 minus x squared over 4. What's this? Okay, so if you try and factorize it, there are two real root here, -2 and 2. Okay, and then you have a graph look like this. So it says that the base of this solid, right? You want to find this base first, is bounded by this curve, x-axis and y-axis. And if you notice that actually there are two parts, right? So that's why they say first quadrant. Okay, so only this part in the first quadrant. Okay. And then it says that, so this is the base of your solid. So how does your solid looks like? So meaning you need to ask yourself, what's the height? Okay, what's the height here? So it is given by this question here. It says that the cross section perpendicular to the x-axis are square. So this height actually is a given by a square. Okay, so what does it mean by square? Both sides have to be the same. Okay, both sides have to be the same. So the square maybe looks something like. So who decide the length of your square? Perpendicular to x, not right? So this is perpendicular to x. So who decide your side? Actually, your y will decide your side. In particular, it decide your height. So this height here also change based on your function. Okay, so your function is like decreasing, right? So can you imagine this solid has a decreasing height as well? Okay, so they say here the square is like this, here the square is 0. So you can form a solid like this. Imagine. Maybe this green is not very good, huh? Let me change a little bit about this one. And this one is a dot. And then this is a bigger one, right? And then you form a solid. Maybe use another color. Imagine. So you have like a square, big square, and then getting a smaller square, smaller square, smaller square, smaller square. So you have a big square, and then smaller square, smaller square, smaller square, smaller square. Join together.
And base is our
Base is this first quadrant. So this side here is like a bit curvy. And then the top also follow this curve. Imagine. Imagine or not? Cannot. So first, do you get the square yet first? Did you get the square? Okay, you get the square, right? So for every height of your y, you get a square, and then you join this square together. You put more square into your picture. Anything to share here? Anything look like this? So far, unless some people got the eraser or a very fat pen, maybe eraser or very fat pen, you can see this. Do you have something look like this? Anyone have this similar structure like this? Yeah, like this eraser, right? This eraser. But a bit curvy, this one. This one is more curved than the. Maybe I need to shake it. Yeah. And then, so here is a bit sharp at the tip. Okay. Okay, so how to do this integration then? Okay, how to do this integration? Well, so the problem here is so the question here is, okay, so the idea of Riemann sum is we take a bunch of rectangle or we take a bunch of cylinder, okay, or take a bunch of this, but now we take a bunch of square, cross-sectional area, okay? So the point here is you need to figure out what is the area of the cross-section. Okay, so what's the area of the cross-section here? So this is given by y square. Okay, y square, which is 1 minus x square over 4. Okay. So this is which is square perpendicular to the axis. Okay, so if you want to put a bunch of square together, actually not a square, right? It's not a cube either because we want this dx to get to 0. Okay, so our V is equals to the integral from 0 to 2 of this area here times times EX. Okay, so the hello, wait, okay, so the law resolution of this thing is the square with distance with thickness, but then the high resolution is this solid here. Okay. So if you just do this part here, this is a law resolution. Okay. This is a 360p. But once you do integration, you will get a 180p here. Okay, because you take the limit of your thickness to 0. Okay, you take a thickness to 0, then you just have a bunch of square that line up in your solid. Okay. Question? Any question? So far? Okay. How about let you grow some idea? How about this? Try and describe this question here. You imagine what happened here. Yeah, how does this cross section look like? Yeah, try and look at this. Okay, so what's the base here? So the base here is controlled by y equals to sine x. So y equals to sine x like this. And x-axis. Okay, so potential is all these, but it just says that one of it. Okay, just take one of it is enough. And each cross section perpendicular to the x-axis, again perpendicular to the x-axis, is an equilateral triangle. Yes, so you should draw a triangle on the top. So I draw a little bit slanted, so that it's easy to see. Okay. So the highest one should be at the top, right? At the middle one. Okay, and then the lowest one is just 1 point here because there's no side. And then you will have some small rectangle growing because the height is increasing towards the middle. And it's quite symmetry. And then the solid is by joining these together. Okay. So it's like something like this, and then that grow up, then you have something like this. What's this? This is like a chestnut. Chestnut? Not really like chestnut. Chestnut is quite curvy, but this one is flat. Maybe you can get a chestnut. So let me find a chestnut diagram. Let me find a chestnut diagram here. Is there a proper chestnut diagram? Could be chestnut, right? Maybe something looks a bit like this. I obviously need to slice part of it. Maybe a closer one. Where's the closer one? Maybe something here. This one. So you like slice to half. Right. Is it close enough? Close enough? Okay. Right. So yeah. Okay, so what's the cross-section area here then? So the area is the triangle. So it's half time the base time height. So the base is what? So the base is sine x, but what is the height? This is an equilateral triangle. And so your base is sine x, and then every side is sine x. But do you know how to find your height? Square root of sine square x minus half of sine square, half of sine x, and then everything square. Okay, so half of sine x squared. Okay, this is your area. Okay, and then what do you do for integration? So you integrate from, let's say this is 0 to pi of your cross-sectional area times your low resolution triangle. Okay, and then take to infinity, become an infinitely many triangle here. And then this is just integrate from 0 to pi of your. So this area was simplified to square root 3 over 4 sine square x. So you'll be integrating this. Yes. Okay.
P,
What P?
like in a volume.
Volume? Yeah, volume. This is volume.
And there is no extra P,
You mean what's P?
like 3 or 1, 1, 5, like that. Extra value, like in a
Washer? What's P?
the number.
Pi.
Pi.
Oh, pi. Yeah, pi. Okay, so where's the pi come from? Where's the pi come from? The pi is the area of the disk, pi r squared. But here the area is not this anymore. It's a triangle. Just now is a area of a disk because you revolute. So you trace out a circle. But here the cross sectional is triangle. Does it make sense? So the point here is we change the cross sectional area. Okay, just now we use square. So here is just a formula for a square here, right? But here the area become triangle. And then previously, the cross-section area is circle. So pi r square. Okay, pi r square and then r square and then half of base time height. Okay. Any question? No? No? Uh, should we go a bit longer and then we'll take a break and then we'll come back for quiz? Is it okay? I take 10 more minutes and then take a break and then we come for quiz and then we finish. Okay. Okay. Let's go a bit further and then we will break. Okay. Next part is a bit trickier. So now instead of this, we will compute it using a cylindrical shell. Okay. So what is a cylindrical shell first? So it's a solid bounded by two concrete concentric right circular cylinder. Okay. So how should imagine this? So one cylinder is like this, and then the other cylinder is like that. Okay, so this is called a cylindrical shell. Actually, you see this shape before, right? This is actually a washer. But just now our washer is facing X direction. Again, now this washer is facing Y direction. Okay, just now we also deal with the Y direction as well. Okay, but what we're gonna do here is there's another way to see this shell here. So this way to see the shell is no example here. I think I put it here already. Okay, so the volume of the shell is like this. Okay, sorry, pi r square, pi r2 square, pi r2 square minus pi r1 square times h. Everything times h. Okay, so does this make sense? Does this make sense here? So let's say this is your shell, and we have the outer one. Okay, so the inner one is R1, so that's the one that you take away, and then the outer one is R2. Okay, so you want to compute everything in the middle. So you take the area times the height, you get the volume of the shell. Okay, but then after what do? You rearrange them. Okay, so if you rearrange them, you get pi times R2 plus R1 times R2 minus R1H. Then what did you see here is if I rearrange into this form here, so what's this form here? So this form is 2 pi times R1 plus R2 plus R1 over 2 times height times the distance between R2 and R1. Okay. Okay, so what did you imagine here? What can you imagine here? If R2 get really close to R1, okay, if R2 get really close to R1, okay, I urge you to keep this picture in your mind, cylindrical shell. If this R2 get really close to R1, what happens to R2 plus R1 over 2? Maybe you can think of R2 getting close to R1 or R1 getting close to R2. Then R1 and R2 is just the same. Okay, so in the event of, so let me draw it. In the event of R1 getting close to R2, what you get is just really a cylinder. Okay, what you get is really a cylinder. Does it make sense? Okay, so this is another way to compute volume. We use cylindrical shell to compute volume. So the cylindrical shell above is like a low resolution. After taking R to R2, this is a high resolution. Okay, so this is another way to compute volume. Okay, so here's the thing that you can look at. So let's say we want to compute this high resolution thing. Meaning we evolve the plane region here around y-axis. Okay, and then you can see that there's something get removed from the middle, right? Okay, so then in this case here, we can use a cylindrical shell to approximate this volume here. So the bottom here is this. This is the bottom. Okay, first is 144p. Okay, 360p, and 1080p, and then above is 4K. Does it make sense? So this is approximating, just approximating. And then that is the actual solid you want to get. Does it make sense? Can I understand? I use the YouTube analogy. Okay. 360p, 1080p, that one is 4K. Okay, so we take this thickness of the cylindrical shell to 0. Okay. So that your volume is like like this. Okay, so you take a bunch of cylinder actually. Instead of cylindrical shell, you take a bunch of cylinder, add them together. Okay, so this is how convenient our integration is. Integral in particular. Okay, so actually you are adding a bunch of cylinder. Okay, makes sense? Okay. All right. Let's use this idea and compute one thing and then we will break from here. Okay, so the formula you want to remember for this cylindrical shell calculation is integral of 2 pi x fx dx. So what is x here? X here is radius, and then fx is the height. Okay, and then thickness is the, I mean, dx is the thickness that we will take to 0. Make sense? Okay, so you have a radius, and radius is controlled by x, and then fx is height, and then thickness, you will go to 0. Okay, so this kind of rotating is rotate about x-axis. Okay, so you should imagine I also can rotate about x. So this is rotate about x-axis. You also can rotate about y-axis. Okay, right. So this is good already. So let's try example on this. Let's do this and then we will break from here. Okay, so the region bounded by y equals to 2x squared minus x squared here. So draw it for you already. And the x-axis is revolving around the y-axis. So the shape is maybe coming. So you rotate. It's like a mountain, right? You rotate the mountain. Find the volume of the resulting solid. So you can use the previous method to compute this question, right? So which is the radius in and radius out. But can you figure out what's the radius in, radius out here? Can you figure out what's the radius in, radius out if you use the previous method? What's the radius in? What's the radius out? Like this, right? Radius in, radius out. No, radius in is here, radius out is here. Okay, but can you describe here or not? Can you describe the radius out here? So meaning can you write x equals to something in y? So then you need to solve what is the cubic solution here, which is kind of hard. Yeah, it's kind of hard. So instead, what we're gonna do is we're gonna use the cylindrical shell to solve it. Instead of using the disk, we will use the cylindrical shell. Okay, so how do we use cylindrical shell here? So you need to be able to see cylinder here. So what's the cylinder here? What's the radius? So what's the cylinder here? The cylinder has radius what? What's the radius? Who control the radius? So the radius is x. Right. The radius is x here. Okay, all the way from 0 to 2 pi. Okay, because you got a cylinder starting from a point and then like that. But what's the height? Who control the height of the cylinder? So your radius is ranging from where to where? For x in between 0 and 2. Okay. And then what's the height? Who control the height? Who control your height? When I draw this cylinder, right? Who control the height? It is controlled by the function here. Okay. So this cylinder has height what's the height here? The height here is 2x squared minus x cubed here. Okay, so if you're gonna use this volume, okay, volume you integrate from 0 to 2 of 2 pi x, the radius is x, and the height is 2x squared minus x cubed dx. Okay, so 2 pi x here is radius, and then 2x squared minus x cubed here is height. Okay, and then this thickness go to 0. Okay, so this is much easier than to find what is x right, what is x out, what is the radius out, what is the radius in. Okay, that one is much harder because you want to solve the x cube solution. Okay, any questions so far? Question? Any questions so far? Okay, the shape you're gonna get is something look like this. This is the shape you are getting. What is this? This is a bit like you know when you're cooking, you need to smash your garlic. Smashing your garlic, the bowl to smash. What do you call that? Anyone? No? Yeah. Maybe something like this. Yeah. A bit smoother lah. Smoother than this. Smooth a bit. Okay. Yeah. Yeah, so this will be easier than finding the radius in and radius out. Okay, any question? Maybe next time we can come back from this, and then we will try solve some problem using both way to show you that maybe which one is easier to use sometimes, depend on what you have. Yeah, any questions so far? Question? Okay, so I think one thing you want to remember from today class is we're kind of slicing area or we're slicing volume into some basic shape. For example, disc, for example, triangle, for example, square, for example, cylinder. Okay, so these are the basic shape we want to slice our space into. And then we use the integration to help us to find the area of volume. Okay. 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 So in the Riemann case, Riemann sum of rectangle case, we have rectangle and then thickness getting 0 become a line. And then we have the disc, this with thickness also go to 0 become just a disc. And then circle, no circle, rectangle, sorry, cube right. And then we take cube to thickness 0 become a square. And then triangle, okay, we have a prism of triangle, and then that prism have this thickness 0 and then become a triangle. And then now cylindrical shell, okay, with thickness go to 0 become cylinder. Okay, no? So this is the point. Okay? So the thickness, the non-zero thickness, you can think of it as a low resolution, not smooth. Okay, when we talk about low resolution, it's like not smooth. It's like there's a staircase. It's not smooth. Can you give staircase to disabled people or not? You know, disabled people, they need to push the wheelchair, right? Can you give them staircase? It's not smooth. Okay, so we want it to be smooth. So that's why for disabled people, they will prepare a, what do you call that? A ramp. Okay, so you can push the wheelchair out. Okay, smooth. Okay, so this bottom is like, here is like not smooth. Okay, and then the, where's my picture? Oh, sorry, yeah. I think I should go here. So here is like not smooth. And these pictures are not smooth. and then the original picture is smooth and smooth. Okay, question? Any question? No? Okay, in that case, let's break until 11:30 and then we'll come back for quiz. I mean, discussing quiz result. So 它是说 volume of solid generated by moving the region， so 你先把这个 region 画出来。对它的对这个你可以对哪一块？黄色那一块，不对，
对这一块
红蓝色吧？对对对，就然后你就拿那一块东西，那片叶子这样子转吧，
就只拿这一块。
就把那个去，对，就拿这个去。
那为什么就是说，而这一块这个时候它们也是这首是在这一块的时候，它不是在二上面。那然后那这一块应该是它给它加的，因为这上面是在还有一个黄色加的。
对，你拿着这一块叶子，然后你就
老师，我认为
去认为，
就是不止这一块是它的 region，
你认为哪里？
就是这一整块。
它是 y 等于 x square 嘛，因为 y 等于 x square 为这个，然后 x square 等于8x 这一个，
对，我觉得
所以它要两个包，被它们两个包在一起。哦，又在这。哦，想想，可是你如果选这一块，它就不包了，它就无限了，就无限了。
这个也说，我们是这个应该归选不考，但是为何移到位4去？
对，
因为 chapter 5它就是那个 division，就是前面
对对，
就是其实后面它都会给，
我们会给我们
学过，
我们觉得我们要给，对，
那
就是
觉得要给的就是，
比如说，
好像
我们只会给一些 trigger identity， 然后会给一些，比如说 intermediate 的 Lutheran 嘛，比如说那种什么 chain rule 啊 product rule， 那时候你们应该要走，
对对对，
你不熟也走不出。
对对对，老师，那有没有这个什么以前就是说我们要做什么？
只要其实就是 textbook 的练习吧，然后 lecture 的练习，题目就类似那种。
哦，那老师之前那个 quiz 它要公布已经本来是
我已经派回去了，只是我们等下讨论一下。
已经派回去了，
你派回去，你可以去发给我。
有一个动画的
都派了吗？你刚刚
我那里一个没有啊，我那里
啊？那可能？你怎么可能？你开一下你的模的。
哦，
QE 我们已经讨论过了诶，我不知道你没有在啊。不可能啊！
我刚才看了一下那个模的，我上面
不可能啊！你开看，你开，
我现在看，
你看看，你看，不可能。再带回去给你了。还有一个 feedback 啊，你
是这就不是在这里，
不是，不是，那个只 grade 罢了，有那个 file 的。
哦，
对，
那可能是我看错地方。
对。
哦，这个底下的那个，
对，
原来是这样。
对。
哦，好嘞，好嘞，谢谢老师。
Yeah.
So basically, what we're questioning is it says that everything is square. Like so, basically, it forms like in that inside of the volume, there's like a lot of squares. And then why does it call squares? We're supposed to.
Oh no, it just saying that the cross section are square.
What do you mean? Can you?
So like cross section. So I mean I did draw the diagram now. So wait, let me check. So it didn't say that the whole solid is a square, but the cross section is a square. For example, a cylinder. What's the cross section? It's a circle, but
Yeah,
cylinder is not a
it's not-
sphere.
wait.
没有，它这个 this is just cross section is a square. So are you saying that it's not a cube? Huh?
Yeah, it's not.
It's not a cube, right? But the cross section still can be a square.
But the thing
The
is-
square is getting smaller.
Yeah, but the thing it's not a square. Like
Mhm.
the shapes is basically rectangular.
The shape is not rectangular as well. It's like a,
Because
Mhm.
the y-axis is
Mhm.
like, okay, for example, if x equals to 0, then that means the y is 1. And then if the if the y equals to 0, then that means it's 2 equals to 2. So by that means this it's not square.
then I draw the square up.
Yeah.
Yeah.
Like what we're trying to
Is it-
say is like if we shape it into here, then like for example, if we've already reached to the max, then the the sides are like 1 and 2 if we input the y equals to 0 or x equals to 0. So we thought that it's not a square, it's like rectangular. A rectangle, sorry. That's what we're
What you
confused
doing?
of.
What are you doing? Let me see what you do. Y equals 0. And then this is -2 and
Yeah,
2.
so there's no 2, right? Because
Yeah, so and then x equals 0. And then y equals 1. And then so what's wrong? What's this with this square?
Tyler one was confused, like why does it call it square where when the illustration is supposedly rectangle?
Where's the rectangle? You don't have the height here. Yeah? You don't have the height, right? So we impose the height to be the same as the
I thought
side
the height is supposedly here.
no. The
What do
height.
you mean by
So there's supposedly there's a z direction coming out.
Mhm.
There's a z direction coming.
Oh, sorry. So this one is the flat. And
Yeah,
then
yeah,
there's
yeah, yeah.
Okay, so
Yeah,
this.
yeah.
Okay.
So you need to push this thing. 这个是 this is the z direction. This is the z direction. 这个什么形状？就是说 like 这个你有高这个 height 这个 you have this height, right? And then you use this height to put a square on top of it.
Ngerti.
This is the z direction. So
Right.
your x is
Okay.
here, your y is here, and then your y equals 1 minus x squared minus 4 is here.
但是
啊
通过这个就这个
And then from here, and then you build this height.
这个高，这个的高，
对
歪的
对对，
这样竖起来一个正的，
对
正的形状
对
这样
对
爬上去
对。哎，你看这张图，看得到吗？呀，
那相当于这个这样立起来的，这样这边的长度是多少？
0到2，0到2呀，
对
对，没有错，高度也是0到，
0到2，
这个是2吗？
这个是这个
这个1，这样这个就是1咯，很高度就是
这个这错写的，
呀，对
Wait. Try. Okay, so basically from this is like the flat surface, which is the y and the x, right? And then there's the z. So by that means we can illustrate the square and
Continue.
no, like I'm questioning, like,
Yeah.
can you illustrate this?
I mean like the square is like the height will be using this height here. For example, this is the side of the square, right? And then this height, let's say this is 1. So there's a square like this. So with height 1.
Okay. So
then
that's why
It will decreasing like that.
here. Okay. Yeah, I understand. Thank you.
Okay.
Yeah.
Hello, testing. Good. Yeah. So when we discuss this kind of cross-section volume, remember that there's an extra z direction. Yeah. Because this is just a base, so you should have another z direction. It's like going to 3D already, and this is what you are gonna see in your calculus 2. Okay, calculus 2 will be all during this time. Okay, this is actually 3D height in 2D. We just solve using 2D because in the height direction is not changing. Then when you go to calculus 2, this height direction will be changing. Okay, so you use the double integral instead of one single. Okay, let's discuss quiz. So you should be able to find your feedback file inside your quiz too. and then you can bring it out and check with me. So I will gonna post out the solution afterwards, but I will have a lot of add-on, and on this solution. I think it's not here. So make sure you take notes because some of them is very important for your exam. You need to write your argument properly, otherwise your marks will be taken off. Okay, we have improved average this time. We improved our average this time. This time our average is, let's see, this time, yeah,
Average is 20.
how is it possible? Everyone have to get 20 so that the average is 20. Okay, so the average is 16.77. Last time was 15.44. Okay, so I can also see that the result have improved, okay, for most of you. And some of you still due to non-submission, you get 0. So please check. And we have a high achiever here. We have like, let me see, who are you? So we have C He, Shiman, right? Shiman, C He, and then Junjie, Xingyang. Where's Xingyang? Let me see. Okay. Bingchen. Where's Bingchen? Okay. And then Gopagani also do very good. Okay. Arthur come back already. And then Brandon, Margaret, Gabriel, very good, quite good. Yeah, okay. But this time there's no 20 full score here. They're slightly away, just 0.5 away. So let's discuss what's the problem here. And then check whether I have marked your quiz correctly or not. Or you have one point mixed out, you can claim for me later. Okay, so let's listen carefully how we take care of marks here. So first is to find the derivative of this. So maybe you will realize that, oh, it's like chain rule doesn't work, product rule doesn't work, closure rule doesn't work. Okay, so there's really one thing you should do here is to bring the power down first. So one way to bring this power down is use the logarithmic differentiation. And then you might see that why we set x equals greater than 0 here, because we want to make sure that the function is always positive before we can apply log. Okay? Although this is not written in the solution, make sure you know what is happening here. I think people just write these 3 lines, but we gave mark. Okay, once you have these 3 lines here. Also, people trying to use a chain rule, right? But if you, sorry, substitution, yeah, chain rule, correct. So you want to use substitution, which is chain rule here, but you realize that there's still x left over here. So you can't really deal with this like half-half substitution. Okay, so but if you go to calculus 2, there's a different thing which is called partial derivative, where you can see one variable as a constant later. But this is not what we want here. Okay, so some of you use chain rule, so it doesn't work. Okay, because you still have x left over after you substitute u. Okay, next. It's quite straightforward. Okay, 2 is a bit technical. Yeah, 2. First, we give you a function sine of modulus x. X is in between minus pi to pi. Find all the critical point. So there's no need to show your state here. So this for this question is like if you guess, you also get marks. But in the exam, it's different. No? We ask you to show. Okay, so later I'll tell you what's the thing. Okay. So critical points here, people kind of missing. Okay, you only remember stationary point, or you just remember singular point. These two, you all forget about the endpoint. Okay, this question a bit tricky. They fix the domain. So this domain is like not real number, not everything. So there is an endpoint. So endpoint you need to consider as your critical point. There are 3 types of critical points that you should remember. Endpoint, singular points, and stationary point. Okay, endpoint meaning the endpoint of the domain. Okay, if the domain is R, then there's no endpoint. But other than that, you should have endpoint. Endpoint is like the two sides of your intervals. Okay, for this class, you can understand like that. For B, I think it's straightforward. You just put your critical point to it. For C, what do? You just compare all the value of f in this point. See which one is the largest, which one is the smallest. That's it. Okay. But okay, let me tell you something that you want to take note here. So something you want to take note here is how to show a singular point and a stationary point. Okay. So to show something is a stationary point, you should differentiate your function, let it equal to 0, and then solve it. To find singular point, you need to prove that it is not differentiable at that point. Okay, not differentiable, there's only really one definition. You need to use the limit definition. Okay, left and right. The derivative doesn't exist. So derivative of the secant doesn't exist. Okay, the sine h minus sine 0 over h minus 0. Okay. Okay, so on one side is 1, on the other side is minus 1. If you still remember, this is how we prove the modulus x is not differentiable at 0. Okay, so this is the thing you want to take notes. Okay, this for sure exam will test you one. So you want to take note of this kind of okay, and actually this shape is like this, a mustache shape. The mustache shape. Okay, so you have absolute maximum at where? At minus pi and power 2, and then minimum at minus pi 0 and pi. Okay, so your shape restrict to this. Okay, so the 3 absolute minimum is like this, and then the maximum is on the like that. Okay, because you are just restrict from minus pi to pi. Okay, anyone, did you plot out this graph and check your answer or not? You are at home, right? You should be able to plot some graph and check. Maybe in exam condition you cannot draw it, but you can plot this graph and check. Okay, and by extreme value theorem, this is where you can find your absolute maximum and minimum, which is at all the critical point. So you find the critical point and then you compare them. So which one is the largest, which one is the smallest? Okay, any questions so far for this? For this question? Okay, so if you miss the endpoint, we will take away 1 mark for 2A. Okay, so for those who get 19 marks, maybe because of this. Yeah. Okay, so you are missing point to check. Okay, you are missing point to check. Okay, question 3. You are given these two function here, and then ask you what's the intermediate form. Okay, so we are preparing you for L'Hopital rules. Okay, we are preparing you for L'Hopital. Very good that every one of you try to compute what the limit and x goes to 0 and then show that it's 0 over 0. So this solution here is not kind of complete. You need to add in your reason. So I have added my reason here. Okay, I think most of you did this, which is good. And second, once you have this intermediate form, you can use your L'Hopital rule. Okay, you use your L'Hopital rule. Some of you, there's a calculation error, so such that you don't get 1 over 4. But most of you is fine. Yeah, any questions so far for this question? I think this question is quite straightforward. Okay. Next question is again tricky a bit. Although this question seems very simple, but there's a kind of tricky part here. Okay, so what's the tricky part here? So let's read about question first. A car starts from rest and accelerate along a straight road. Okay, so you got a road. Okay, and then you got a car. And maybe you got a Mercedes here. Okay, so accelerate from rest. Due to the air resistance, its velocity does not increase indefinitely. Okay, so it just says that you cannot just increase forever. Suppose the car's position st in meters after t second is modeled by this following function here. So meaning I give you a t, this st will give me a position. And this st will give me a position. So find the velocity and acceleration. So this is very easier. So you just differentiate once, differentiate twice. We even give you the hint. Do you think this hint is necessary? Let me interview you. Do you think it's not necessary, huh? Because you should know what is velocity and acceleration already. But we are very kind. I will tell you what's this velocity and acceleration. Next, determine the interval where this function is increasing. So what do? You get your first derivative and then check where it's greater than 0. For the x's, they are greater than 0. And then determine the interval on which function xt is concave outward. Concave outward means what? Second derivative is greater than 0. Okay. And then find the t time t that give a local extreme point. Yeah, so you need to either use first derivative test or use the second derivative test, okay, to find it. Okay, but the issue is, for B, right? Okay, people maybe include the endpoints. Okay, in this case, we are fine for increasing or decreasing. We are fine with it. But for C, if you include the endpoint, we will take off 0.5. Okay, because concave outward and downward only care about open interval. If you check the notes out, again, the I is about open interval. At the end point, we can't really say the graph is on the top or at the bottom of the tangent line. Okay, if you check the notes, it's just about open interval. Okay, because the domain here is from 0 to infinity. Okay, so there is a boundary point. And actually, people include the 0 as a local maximum, which is false, but we don't take off marks here because due to the other class. Okay, but we want to mind you that no boundary point for or no endpoint for local extrema. Okay, we will take off marks during the midterm. Okay, for now, we just remind you. Okay. This is what we discussed last time, right? Local extreme, you cannot take boundary point. You cannot take the end. Because there's a no left, right to compare with. To check about local extrema, you need to have a neighborhood around you. Then you are the least one or you are the largest. So at the end point, you only got one sided. You need two sides. I mean, at least for this class, we define it like this. Okay, for this class, we define it. Okay, any questions so far? Yep. Second question solution. Yep. Which one? Any other question you want to go through? You want to ask or you want to yourself one? You want to ask a general one or yourself? Okay, maybe wait for the rest first. Any other thing you are not sure? Clear? Clear on what to do, what to answer during the exam? Is it clear? Happy with your marks? Happy with your score?
It's minus pi and plus pi also critical points. Or no?
Yeah. It is. Critical point, there are 3 kinds of point. Endpoint, singular point, stationary point. These 3 are called the critical point. Okay. If your domain is everything, so there's no boundary point here. Or if your domain is like this half interval here, then there's only one endpoint, which is 0. Infinity is not a point in.
Just I thought that 50 points is like, how can I say? Critical points is a, like, how can I say?
Stationary point.
No, like critical from minus to plus or and otherwise, like
What do you mean by that?
endpoints.
Hmm.
I think there is nothing left in this
Yes.
side, so I thought that it's not a critical point.
Because the critical point here will give you extreme, absolute extreme value. So it could be the case that at the boundary point or at the endpoint, it has the largest or the smallest value. It could happen that. Okay, so we need to include those in. Yeah. If your graph might not have local maximum or local minimum. Okay, so your graph might not have local maximum or minimum, but the highest point occur at the boundary.
So critical points is the endpoints in this.
Critical point, yes. Yeah, it's the minimum one. Because maybe you have a local maximum, okay, but it's not your absolute maximum. The maximum absolute maximum might occur at the boundary. So these stationary point are not extreme, absolute extreme. Okay. Yes, we don't take boundary point because for concave up and down, if you look at the notes, we only care about open interval. Okay? We don't care about the endpoint because we can't really comment about boundary point. Okay, other question? No more? Okay, good luck. So far so good. Okay, good luck with your revision. We will see you on Wednesday again and then Friday. Okay, I will post out the solution after the class. Yes, sure.